Hello, good morning, everybody. Okay, so this is Mark Churley from APPtechnology, and I have on the line with me Barry Daniels and Michelle Laverick from Droplet. And
Hello.
Today, what we're going to be doing is going through a short webinar that's going to be focused around Windows 2003 or legacy servers. We're going to do a quick intro now, and then I'll hand over to Barry, who will talk a bit more about the product, and then we'll hand over to Michelle, who will do a quick demonstration. So from our perspective, we've been working with Droplet for quite some time now, and typically where we've been working has been in the desktop space. And in the desktop space, we're hopefully all relatively familiar with these challenges. So we know in many enterprises that we work with, there's still legacy applications out in the estate running on NT, XP, Vista, Windows 7. And in many of these cases, they're still running because there isn't an upgrade path. They might be bespoke applications, they might be tied to specific pieces of hardware that are in the estate, or the application is due for decommission but still needs to run for a number of years. So within the end user estate, we've already been working with Droplet for a number of years now, with containers allowing those applications to run and organizations to move forward onto secure platforms like Windows 10. More recently, there's been some developments within Droplet that has now extended that capability to provide support for backend servers. So if you've got complex client server applications that are running on old code, or if you've got any database migrations, also database server migrations that maybe are being held up because of legacy servers, what we're going to walk through today is how Droplet can also be used to support that and allowing you to move away from those insecure servers and those insecure applications. So what I'm going to do now is I'm going to make Barry the presenter, and I will hand over to Barry.
Thank you very much. Hopefully this now works. Can you see my screen okay?
Absolutely, yep.
Brilliant. And you've got the full presentation, not the...
Yep, all looking good.
Excellent. So a quick introduction and a little bit more detail to what we are and what we do. So we are a container technology, and it's important to distinguish how different we are. We're really selling three key things to our clients, and that is the security, compatibility, and compliance. We're not Docker. We don't use Docker anywhere within our technology, and we have a worldwide patent on our technology that is completely different in how they work. That's more for modern applications, there to be distributed across a wide range of server-side applications to control the cost of cloud, and more around DevOps, etc. We're really around isolation of applications and allowing them to persist, and having the freedom to actually distribute those across multiple platforms, run in the cloud, and have a freedom of choice while wrapping this additional security layer around both the client and the server side. So really protecting against those zero-day threats and zero-day attacks. And it makes it ideal for the legacy challenge in that respect. A lot of the high-profile breaches that have come out of recent times have been through exploitation of legacy systems that exist within infrastructures. And so we're a great way of being able to protect that, and we'll talk a little bit more on that going forward. On the client side, as Mark says, once inside a Droplet container, your applications can persist across a multitude of different operating systems, be that on Windows 10, on Chrome, on Apple Mac, on a Red Hat or a Linux system. And we distribute an executable for the different sort of instances we support. We can also support things along the lines of cloud as well, and Citrix. We can persist in Windows or Azure Virtual Desktop, as it is now AVD. We can persist as well in a multi-session kind of experience. And we distribute an executable, and then the same container images gets pushed out across all of those. All of your governance, all of your security is then wrapped inside that layer. And so that really naturally brought us onto these server containers, and our clients that were using the client-side container typically these clients were talking to a backend database or a backend server, and those servers would persist on 2003 or 2008 systems. And there was a challenge in the same way there was on the client side of dependencies locked back to certain versions of .NET or Java frameworks, where the applications couldn't simply be lifted and shifted. And so we moved on to this world of server containers and built the same kind of infrastructure in that respect and that manner. So we can persist across a multitude of different systems, again, in the cloud or on a vSphere. In fact, I would say they're our main two, along with AWS we can support as well, or we can also support a bare metal deployment of our virtual appliance for the server-side container. And we wrap up inside that container your existing ones and zeros of your server side product, and allow that to persist inside the secure container bubble. We have two different types again of container on the server side. We have the 2003 type of flavor, or 2000 or NT4 kind of era, as well as the 2012-28 era of the DCIM or the DCIX type container. And this is the security statement around what we do, and this is the main reason why we persist against that zero-day attack, is we trust no one. So it's not a zero trust which is being put out there in the market a lot. We actually don't allow anything in unless it's our client talking to our server-side container. We persist on both sides of the house. So on the client side, we have the client side there that can persist across the different platforms. No matter what you put inside that client-side container, we don't persist out on the network. We're completely invisible on the network statement on that. And so you have protection for the client-side access to that server, knowing that that's not vulnerable. So if you need an old version of Internet Explorer, for example, IE8, IE11, to talk back through to your server estate, we can protect that in a manner of where we block all inbound traffic. You can control outbound access from the container out through the host, out to speak to the container, and lock it down to only be able to do that. So therefore securing and achieving those sort of cyber essentials plus NIST type compliance. And similarly across on the server side, wherever it's persisting on a VMware estate, an Azure estate, or AWS, or bare metal, what actually then happens is we persist on a Linux distribution. So choose your flavor of Linux. You could be a Red Hat house and have support via RHEL, or we can even support the free supported ones like CentOS Streams, or Debian, Fedora, SUSE. We really don't care what we insist on, and then our virtual appliance sits on top of that. And again, not allowing any inbound traffic except from the traffic that comes from our client-side container. So there's a bubble that wraps around the client side where nothing can access. There's a bubble that wraps around the server side where nothing can be accessed except for from our client. And then we encrypt the traffic between the two so that data in flight can't be intercepted by a man-in-the-middle attack, and obviously gain access to the system from that method either. So it's a complete trust no one model, as I said. So if you look at traditional ways, and there are some products that are out there protecting server, for example, like Trend Micro, etc., and they're looking at behavioral AI, but they're still allowing data to pass backwards and forwards freely. And so zero-day attacks, if they're not aware of the algorithm, if they're not aware of the bad actor or what's trying to achieve and do, they can easily get through the net, as we've seen recently in the high-profile attacks that have happened. So in a droplet world, we're a trust no one model. So nothing can get in at all, good, bad, or ugly on either side of the house, therefore protecting down. And you can limit what an end user can do on the client side completely. And Michelle will go down and show you how we lock down that side of the house as well. And with that, I am going to, one thing I did want to say before I move on, sorry, to the demo, and that's on the server side, 100% of our customers have gone down this route. We can build it from scratch. You bring your own software, you put your software into it. But what we've seen in most cases is a lift and shift exercise from our customers. So we take the existing binaries, the ones and zeros, shift that 2003, 2008, 2000 NT system, whatever it may be, and we take that in its whole state, shifting that into the cloud. So everything they talk to, all the dependencies can all be locked inside this bubble as well. If you need AD authentication, if you need things like that, they can also be put inside the Droplet bubble to coexist, talking out as a parent child to a main AD if that's a challenge that you have. Therefore maintaining that security boundary. And with that, I'm going to hand across, and let me change presenter to Michelle. Michelle, you should have access now to take over on a demo.
Okay, thank you. Can you see my screen now?
Yeah, we're good.
Great. So let me start with just showing you the client product first, because the two components, the client and the server, do lock together, and I'm conscious that people might never have seen even the client side of what we do. So this is a Windows 10 machine, and the client side container is running. Usually this app is suppressed to the system tray, and users double click at icons on their desktop, and that loads up the application, whether that be a legacy application or indeed a modern application. I know our webinar today is focused on legacy, but we do have customers who use us as a platform for delivering modern applications as well. So that's what our client application looks like. As for the server side, in this particular demo, I'm actually running our appliance on vSphere. Yeah, as Barry indicated in the presentation, we can support this appliance on Azure, practically any cloud platform, and it can also run on things like Hyper-V or Nutanix. We're just using vSphere really here as an example for running our virtual appliance. On each of these three virtual appliances, I have got three server-based containers. So that's the first one. If I just wake it up for a second, the second one, if I just cancel that for a second, is this container here, which is based on a 2008 based kernel, and this container here, which is based on a 2012 kernel. So although our focus today in the presentation mentioned 2003, there's a whole host of legacy OSs that we could support as far back as NT4. And indeed, even modern operating systems can run on the platform. But what we find the sweet spot at the moment is currently 2003 and 2008. And we expect over time that demand will only grow for our server product as the windows of end of life start to close on these Windows server-based operating systems, and Microsoft withdraws support completely. In terms of how the client actually connects, that is done through our software. So what I've done is created a little shortcut to one of those servers, container servers, and it's just a web browser based link. And I've also created a link that would allow an administrator to manage one of those containers. At the moment, I am not connected to the Droplet Server Gateway, or DSG. And therefore, if these links are activated by the user, they're not going to go anywhere. They're not going to work because I haven't yet securely connected to the gateway service. So let me do that right now and show you how that's done. Yeah. So all I need to do is click to connect to the Droplet Secure Network, type in my username and password, and that will create a secure connection between the appliance and the layer of server containers that I'm actually running. So just think about that for a second. I've got a bubble of security around the legacy client app, can be legacy or modern, and I've got a bubble of security around the actual server container itself. Once I'm connected to that Droplet Secure Network, these links that I've created to the services that are running on there will actually function. In this case, what I did was just install IIS version 6 to this particular server container with the standard welcome page. So what's happened there is that the client, our client, has fired up. It's made a connection securely to the server container backbone, and the software inside the container is making connection to that web service. So essentially those two bubbles are now linked together by a secure tunnel, which encrypts all the traffic between the client and the server container. This is a very, very good example of our two technologies working together in concert to create a secure boundary around that legacy environment. So this particular web browser I'm using is very, very old. It's IE8, and that IE8 system working inside our Droplet container is making a secure connection to our web server on the same network, albeit brokered and secured by the Droplet Secure Gateway. So that's, you know, the product in an absolute nutshell for people who are looking for a higher level view. Obviously, the configuration of this environment is done from the infrastructure team. The way the appliance is deployed is by using VMware's OVF and OVA format. So we deploy as a virtual appliance, a next affair. There's a little bit of configuration during that process, not least wiring the appliance to the network. In the simplest model, one network is used to manage the appliance, another network is used for where the containers reside, and another network is used for the end user client access. The post configuration of the server is very, very simple. In the networking section, we basically create what's called a bridge, piece of text essentially, that links the network adapters of the appliance to the overall network infrastructure of vSphere in this particular case. So you can see I've got my VLAN 101 here, which is where my containers live, and the client network. Storage options, you've got a whole plethora of different places where you can actually store these Droplet containers. You could store them just inside the context of a VMware virtual disk, for example, in the VMDK, and that virtual disk would be stored on your SAN. Alternatively, you can connect the appliance directly using NFS or SMB or iSCSI directly to your storage system. In this respect, the appliance is just acting as an engine for running the legacy-based container, and all the storage is backed off to the backend SAN system. There's a couple of advantages of doing this, not least the ability to leverage your SAN functionality, such as replication and snapshots, and any backup features that you've got embedded in the SAN. But critically, it allows for us as a company to be able to move the containers dynamically from one appliance to another. You've probably heard of VMware's vMotion, generally referred to as Live Migrate by other vendors. And essentially, you can do exactly the same thing with a Droplet server container. So administrators who are used to things like maintenance mode and being able to move workloads around for either performance or because they need to do some sort of patching and update, you have exactly the same type of functionality in the Droplet server container layer as you would within your virtualization layer. So it's a very, very simple model, very, very easy to set up. And as Barry indicated, we do have the ability to take existing virtual machines or physical servers and convert them into the Droplet format. That's a relatively straightforward process of taking a copy of an existing virtual machine, some modifications to the metadata that backs that virtual machine, and some changes to drivers inside that Windows OS. And then our engineers will use a conversion tool that we have in-house that converts the VMDK, in this case, to a .droplet file. So critically, there's no rewriting or reconfiguring of the software. The ones and zeros that currently exist either on the physical server or inside the virtual machine remain intact and are not modified by us. And that's quite critical because a lot of these legacy systems are now so old, the tribal knowledge that would allow people to rebuild them is simply not there. And there's a high degree of risk in terms of doing that, in terms of duplicating that configuration. So whilst we do support handing over a clean container, for want of a better word, and you bringing your software and bringing your data to that construct, most of our customers go for the lift and shift process that Barry was mentioning in the PowerPoint. And that means you get an exact copy of your legacy system running inside the container. Lastly, I just want to flag up some security and auditing features and concerns, just to sort of give you an idea of what we're doing here. So if an external auditor came into your environment and started navigating around and seeing what was visible, in the vSphere layer, all they're going to see is the fact that there is a modern day Linux operating system. Yeah. So we support a range of different Linux operating systems. The one I'm using today is CentOS Streams, the very latest version of CentOS. But we can indeed port this solution to things like RHEL, Fedora, Debian. So if you've got a mandated distribution of Linux that must be used in your corporate network, we would simply spin up that copy of Linux, sprinkle in our secret sauce, and make an appliance that was based on that particular OS rather than CentOS. So if you think about it, what we're doing is adding a layer of abstraction on top of the vSphere layer in this particular case, and that extra layer of abstraction gives us more control over hiding and obscuring and securing that server OS. Yeah? And also it helps address that issue of support, because this is a Linux-based, modern Linux-based OS, which is supported by the very latest editions of vSphere, for example. The other thing I wanted to mention was how administrators, Windows administrators, gain access to their legacy-based Windows system. We can run RDP in the context of the container, and as long as that administrator has got the valid username and credentials to actually log into that server container, then they can carry on doing their administration of that Windows system unchanged. Now, critically here, the Windows admin has no idea that this is actually running in a Droplet container, and no idea that this is actually running on top of the vSphere platform. So it's completely abstracted from their view. Therefore, that Windows admin does not need any access to vSphere, nor do they need any access to our management layer. All they need to know is a valid IP address for their Windows server and a valid username and password. And as far as they would be concerned, this is an unchanged system from what they were previously managed. So we do very strictly obey the kind of RBAC principles, where no one individual is needed to have access to all the layers of the system. And so there can be a clear demarcation between vSphere admin, Droplet admin, and Windows admin. The last thing I want to say is just to talk about additional security that I could actually apply to the setup I've got here. We do have our own firewall that wraps around the container. Currently, once I'm connected to the secure gateway, that gives me access to the web server listening on this IP address, only accessible from our client and nowhere else. And so what I could do is add additional rules and restrictions that would make this particular container only work in one particular way. So I could, for example, block all inbound and outbound communication and say only port 80 or 443 is accessible to that particular IP address. That essentially makes the client, our client, be single purpose. All they can do is connect to the secure gateway and run IE to that particular web server and no other. And that will stop them using that web browser to surf the web generally. But it basically shuts down and closes down the utility of the application to a single purpose, yeah, such as gaining access to a website. Obviously, I've used IE and IIS as an example here, but we've done this for a number of different organizations and companies. So things like legacy Lotus Notes systems, where companies are still quite embedded into the workflows of Lotus Notes, and it's hard to leave. We've both containerized the server end and also the client end of that application. So that's the demo in a nutshell. I think potentially we might have some questions that we could answer on the Q&A. So back to Barry and Mark, if you can help us out on any questions that have come up in the Q&A.
Perfect. All right, thank you, Michelle. I've not had any questions typed in, so if anyone does have any, if they want to type them in now. Otherwise, Barry, unless there's anything else you want to cover off, just to sort of wrap up what Michelle's done, what we'll aim to do is we will obviously capture this recording and we can share this out with everyone that was on the call. So if some of your colleagues weren't able to attend, you can share it with those. And I will obviously reach out to everyone that attended directly just to catch up. But yes, I've not seen any other questions come in now. Barry, is there anything you'd like to add to wrap up the call?
It is just around that. This is a way to move not just your legacy, but your future infrastructure. We see it as a much better security stance for all infrastructure to protect against zero-day attack. When you think that nothing is allowed in at all, you're creating what used to be back in the day, where everything was on-prem. Obviously, things have shifted out to the edge these days. This is a way of bringing control back to the IT department, because you can lock down what an end user does to the nth degree, and you can also then have control and know that only that client that's got that limited functionality can access that server side. So just as a general security stance now, we've seen this as a big game changer for us at Droplet.
Perfect. All right, well, thank you, Barry. All right, well, I've not seen any other questions come in. So what I propose to do now is I will close the webinar, and if anyone does have any other questions, they can always email me directly afterwards. But otherwise, yeah, thank you ever so much to Barry and Michelle for presenting, and thank you for everyone who joined.
Thank you very much.
Thank you, everybody.